This is an example problem using Newton's second law, determining the acceleration of a system, the value of the tension, the force, in strings connecting a more or less compound object. But we have a table, some surface up here, a 5 kilogram mass, a 9 kilogram mass connected by a string. There'll be some tension T1. Then the string goes over a frictionless pulley, attaches to a 12 kilogram object that's hanging freely in the air. And I put on some of the forces that exist here. There are some that are not labeled, but we have some. Coefficient of static friction 0.26, kinetic coefficient 0.17. And our first question, do the objects move? Well, we're going to have 12 kilograms times 9.8, the force in this direction. Because there is friction in the system, there will be a force of friction. Now, which way do you think we should draw the force of the friction on the 5 kilogram and the 9 kilogram objects? Friction always opposes motion, so we're going to have friction back this way for both objects on the table. Force of friction will be off to the left. So let's calculate that available force of friction. The force of friction is the sum of the two forces. To calculate the situation where we're deciding if we're going to move or not, the static coefficient of friction is the one to use, and the system starts. It's at rest. We'll see if it moves or not, but we use the static. The system is at rest at the start. We're trying to decide if it will move or not. So we take the coefficient times the normal force. The normal force is the force of contact between the table and the 5 kilogram object, and also the 9 kilogram object has its own normal force. The downward force on this object is 5 times 9.8. The normal force just matches that. If it was higher or lower, there would be some vertical motion of this 5 kilogram object, some acceleration vertically. There is none. This object's moving horizontally. So the forces in this vertical direction add to 0. The positive Fn minus the 5 times 9.8 add to 0. So in any case, the normal force is 5 times 9.8. And then the same calculation for the 9 kilogram object. The coefficient, and then the normal force. So if you should put these into your calculator, 12.74, 22.93, they add up to 35.67. And here we have 12 times 9.8, this downward force, and that's 117.6 newtons. So the force we have resisting motion is 35.67 newtons. The downward force of our object is 117.6 newtons. So this force dominates. The system will move. We've answered that question. The system will move. What's the acceleration of the system? Well, we're now in the situation of doing F equals ma. We have to find the net force of the system. And actually, I'm going to use down as the positive direction. So our net force and total mass, we analyze the whole system to start here, the whole system. So the net force, 100, and we only use external forces. So this 12 times 9.8, that's the force of gravity. Due to gravity, that's an external force. The two forces of friction are external forces to the system. The tension, T1 and T2, these are internal forces. This is not part of our calculation for this starting of the problem. Net external forces. The weight due to gravity and the force of friction, those are external to the system. These tensions are internal. All the forces between the molecules of these objects are internal. And good for us. We don't have to consider all those intermolecular forces. So let's go ahead and do this. 117.6. I'm taking that the positive direction. The friction force is in the opposite direction. So now I subtract. I cannot use 35.67 newtons for the force of friction. Why is that? Because now we're moving. Now it's a kinetic problem, and I have to use 0.17. I'm going to lump the two masses together, so 14 kilograms and 9.8. That's going to be our net force. The total mass here, 5 plus 9 plus the 12, and I hope you come up with 26. I hope I come up with 26 kilograms. And then the acceleration that we're trying to calculate. This acceleration will not be 9.8 meters per second squared. If I cut the string, the acceleration of the 12 kilogram object would be minus 9, well, if it's downward, it'll be downward 9.8 meters per second squared. But this A will not be 9.8 meters per second squared. So we have to do our calculation here. 117.6. This turns out to be, if you want an intermediate number, 23.32 newtons for the force of friction. Notice it's less. The coefficient is smaller. Equals 26 times A. So I subtract 117.6 minus 23.32. Then I divide by 26. You should do this on your calculator. And I came up with an acceleration of 3.63 meters per second squared. And the 12 kilogram object is moving down. The 5 and the 9 kilogram objects are moving off to the right, accelerating off to the right. So that's part B. Part C, what is the tension T1 and T2? Now I'm going to isolate, I'm just going to take a look at this 5 kilogram object. And tension T1 is causing it to have this acceleration. We do have friction back this way. So if I take this direction to be positive, T1 minus the force of friction, and 0.17 times 5 times 9.8, that's our net external force acting on this object. The object we're considering now is 5 kilograms, and we have an acceleration 3.63 off to the right. This force, friction, I believe is 8.33 newtons. You got to double check that. So 5 times 3.63 meters per second squared plus 8.33 newtons. I came up with a value of 26.5 newtons for tension 1. I'm sorry, I'm off the screen again. So reviewing, net external force is total mass times acceleration. 117.6 is the downward force due to gravity on the 12 kilogram object. The friction force back to the left, 23.33. Solve this for the acceleration, 12 kilogram object accelerating down at this rate. The 5 and the 9 kilogram objects accelerating to the right. To find the tension T1, I now isolate, and I'm only considering the 5 kilogram object. That's the easiest case here for T1. So the external forces acting on the 5 kilogram object, T1 to the right, force of friction to the left. Force of friction is 8.33 newtons just for this 5 kilogram object. The mass of my restricted system now is 5 kilograms. And the tension 26.5. So give a little more space here. What about the tension T2? Well, now I'm going to consider the 12 kilogram object. T2 and the 117.6 newtons are the external forces that act on this object. And let's let up be the positive direction. As long as you're consistent, it doesn't matter if up or down is the positive direction. But let's let up. So T2 minus 117.6, this is in the downward direction, so it's a negative number. When I combine the forces, T2 is going to be a positive number. And we've got 12 kilograms. Now help me out here. F equals ma. What's the value of the acceleration? What's the number for the acceleration? We have it here, 3.63 meters per second squared down. In this problem, I'm choosing up to be the positive direction. The acceleration is in the negative direction. I must put in a minus sign. You have to look at your drawing, decide which way is going to be positive, and then be consistent with each number that you put in here in doing the calculation. So 12 times minus 3.63, then add 117.6 to the work you've done here, and I came up with 74.0 roughly newtons. That's reasonable. It's smaller than 117.6. We know the object is falling down at this acceleration. It's moving downward. So this 117.6 Newton force has to be the dominant force. So T2 is 74 newtons. And I'll let you keep practicing on Newton's second law and ask your instructor if you have questions.